Hi, my name is Dana Hain, and I'm a science educator with the Institute for the Environment at UNC Chapel Hill. And I also do science education and outreach for the Center for Environmental Health and Susceptibility, which is how I know the two speakers today. I am recording this session because we're going to hopefully make it available to other K-12 audiences. So feel free to just, turn off your webcam if you're not, I don't think you'll be on that because we're going to record like the speaker view only, but just letting you know about that. But I'm going to introduce our first speaker, Dr. Ilona Jaspers, this morning. She is a really awesome scientist who does a great job of communicating about her research. And she's got a great team of researchers, including Elise Hickman, who's also going to join you today. Dr. Jaspers is a toxicologist at UNC Chapel Hill. She specializes in the effects of air pollutants on respiratory health, particularly our immune system, which we all know so much about right now because of COVID, right? We know how important it is to have a healthy, functioning lung respiratory immune system. She's director of the Center for Environmental Medicine, Asthma and Lung Biology at UNC, and she collaborates extensively with people from UNC as well as the people at the EPA, the Environmental Protection Agency, to research the health effects of air pollution, and that includes looking at wildfire smoke, cigarette smoke, and e-cigarette aerosols, for instance. And before I turn it over to her, why don't you, if you have the ability to do a thumbs up in the reactions, let me know if you ever heard about a toxicologist before, if you know what a toxicologist does. And this will give us a sense of how many of you. Oh, good. So I only saw one thumbs up. That's great. There might have been more and I might have missed them.
There's some error if someone doesn't know how to do the thumbs up then.
Oh, that's true. Okay. Well, anyway, I'm imagining when I was in high school, I did not know what toxicology was. I did not know a toxicologist. So today you're going to be learning a little bit more about what a toxicologist is and what they do. So I'm going to turn it over now to Dr. Ilona Jaspers. And I think someone on the call here has a question for Dr. Jaspers. So feel free to ask that first question. Thanks for being here today.
So good morning, everyone. I don't know whether I should be waiting for the questions, but I have to tell you guys, this is kind of fun because I literally have two kids myself who are doing this exactly what you're doing right now, just from the sort of opposite side. They're a little bit older than you guys, but they're in the same boat. They're probably Zooming right now with their teachers as well. So, so we have like 3 Zooms going on in this house right now, sort of either teaching or being taught at the same time. So do we want to go ahead with the first question, or do you want me to give you a little bit of background? I can do it either way.
Since we have a lot of questions, maybe we get started on the questions so we know we have enough time. Our first question is from Lucy. So Lucy, could you unmute yourself and go ahead and read it?
What fascinates you about our respiratory system? What made you interested in studying the impact of air pollution on our lungs?
Well, one of the things that I think people don't realize is that the lung of the respiratory system is really exposed the most to anything that we encounter in our environment. We usually think about the skin as really the sort of first contact with the environment, but the skin is really only a fraction of what the lung really terms, the sort of lung surface area that comes into contact. And if you think about, we're taking a breath, every few seconds, so many breaths per minute and so many breaths per day. And with every breath, there's about half a liter of air that goes in and out of your lungs. So there's a lot of stuff that comes in contact with your lungs on a daily basis or on a yearly basis. There's a lot of air that needs to basically get filtered or that could potentially come in contact with your lung. And even though we're aiming to have very clean air, there's obviously a lot of bad things in the air that could modify or alter the way your lungs respond. And this is obviously very much in the front center news right now when we talk about COVID and the virus particles that can come into your lungs and can actually make you sick. But the same thing is true for air pollutants. So we're coming in contact with a lot of air pollutants on a daily basis. And I'm just fascinated by how the lung can sort of deal with it.
Awesome. Our next question is going to be read by Eloise.
How does smoke from wildfires contribute to air pollution?
So that's a really excellent question. And I don't know whether you guys remember earlier, just a few months ago, the big wildfires that were going on the West Coast in California and Portland all the way up to Canada. And so a lot of area, big area burned on the West Coast. And these, you know, when you think about, you have a fire pit outside or you have a small fire, you know, a campfire, right? So that's a small fire, but you are generating smoke, even in a small fire. So think about now a fire that has like the surface area of the state of Rhode Island, right? And so you're now generating a large amount of smoke. And that smoke doesn't only stay where the fire is, but it gets transported all over the place in terms of the United States and elsewhere, even up to Canada. So the air pollution that is generated by the fire goes everywhere. So the people that are in the stream of this sort of cloud, just like, you know, think about you being around a campfire. You know, when you inhale the smoke, you're basically being exposed to this wildfire smoke for a very short amount of time. But now think about this being like 100 times worse, right? The fires are much more raging, they're much greater, and you're potentially a firefighter that needs to take care of the fires. So there's a lot of exposure to people that are trying to fight the fires or people that are just quote unquote in the line of fire. So all of these people are potentially exposed to the wildfire and to the smoke, and therefore it could cause, you know, sort of adverse health effects.
All right, our next question will be read by Nathan.
Will smoke from wildfires cause lung damage, and is it as harmful as smoking is?
So Nathan, that's a really good question. And we're just starting to understand the health effects of wildfires. But let me go back to a little bit more how complex wildfires are. So if you can think about, go back to the campfire, right? You know exactly what's in that campfire. You have a couple of logs of, you know, oak or pine or things like that. So you know what's in there. So it's really nice, good wood, right? So, but now you have wildfires that are sort of taking up a lot of other biomass, like, you know, now you have pine needles, now you have sort of regular shrubs that you have in the yard, but you also now have potential houses that are on fire. So the complexity of the chemicals that are being generated because you now have a fire, you probably have seen this where when you have a campfire and all of a sudden you put something else in there, like, you know, like a piece of plastic or like a different piece of wood or a piece of garbage, all of a sudden the fire smells very differently. Well, that smell is an indicator that it's very different chemicals. So we don't know yet what chemicals are being released. We have some idea. And so we're starting to make some discoveries about what sort of these health effects are. So we already know that it can modify the susceptibility to a viral infection. We've done that. It can definitely cause some mild sort of inflammation in your lungs. So sort of some mild symptoms, some sort of shortness of breath, things like that. So we're starting to understand what the health effects are. But this problem is really complex and really complicated because, again, going back to the campfire, you don't know what the campfire smells like because it depends on what you put into the fire. And that's the same thing is true for any wildfire. You don't know whether it's just the trees and the shrubs or whether it's also, a house that's now being burned, or a car, or other things that are basically in the line of fire. So it is definitely damaging to the lungs. We definitely have some irritation, some shortness of breath. Certainly people that have underlying health effects like asthma or things like that, they should be really not going outside and being very careful with that. So there's definitely health effects that we already know, but there's a lot more work that needs to be done.
Our next question is read by Justin.
Why did you become a scientist, and what is your favorite thing about being a scientist?
Justin, that's a great question. So I was always interested in how things work. I wanted to understand like how chemicals can sort of change things in your body. And this could be a good chemical, like a pharmaceutical drug, or a bad chemical, sort of any kind of toxicant you come into contact with. So I've always been interested how these kinds of chemicals can sort of modify how our body works, how our cell works, how our sort of biological systems work. So I've been interested in that probably when I was about your age. And so that's, I've been sort of really intrigued by that all along. What's my favorite part of being a scientist is there's many parts. This is actually starting to become one of my favorite parts, is talking to people like you and exciting them about science as well. So that's one part. Another part is just sort of understanding new ways how toxicants can affect and change biology. That's a really fun part when we make a new discovery. And then the third part that I really love about being a scientist at a university is being able to train the next generation, which is people like Elise. So it's really fun to be around young people and their energy and their new ideas. And so that's what I love about being a scientist. So it's really sort of making new discoveries, helping people understand potential adverse health effects, really helping protect people from bad toxicants, helping them understand that, really protect the people, the vulnerable people that are potentially have pre-existing conditions or are exposed to high levels for whatever reason. So making these discoveries, talking to people, and really exciting the next generation about scientists, and training and mentoring them. So those are the best parts of my job.
Tarinda has the next question. And Tarinda, I sent it in the chat, and hopefully you saw it.
What is the hardest part about being a scientist?
Yes. The hardest part, and sometimes the most frustrating part, is that you have an idea and you're really, really convinced that this is true. But your science and your experiments don't show that. So that can be really, really frustrating, but at the same time, it can actually uncover something very novel and something very different. The other part that's frustrating about being a scientist where I am now is that I don't get to do as much science anymore as I did, let's say 10 years ago. So that's a little frustrating. More importantly now is that, science is really agnostic, and meaning that it really doesn't mean, it doesn't really matter who you are, where you are. Science is science, facts are facts. And sometimes it's science gets sort of torpedoed and made into something that it shouldn't be. So sort of the purity of science and what it is, just fact finding and really educating people about scientific facts and knowledge. That's a little frustrating when that gets sort of taken out of context.
All right, and our last question for Dr. Jaspers is from Jay.
Okay, so my question is, What advice do you have for teenagers or kids interested in science? What science would you recommend learning now?
So, of course, toxicologists always need new creative minds. So, this is a little self-serving. So, get into toxicology. It's a great discipline because you get to do a lot of different things, work with a lot of different people. And your science, by definition, has meaning to people because we don't study things just for the sake of studying, to have sort of like an abstract theme, but we're studying compounds that people come into contact with on a daily basis. So big shout out for toxicologists. But sort of in terms of getting involved in science and what kind of science, you guys are really at a great place right now. There's so much science out there that is really available at your fingertips without, like, even in your home. There's so much things you can do. One thing that I missed that really wasn't as available when I was growing up is really sort of become familiar with computational learning and coding, sort of really big data science, because that's where we're heading. Generating data is actually pretty simple these days, but sort of really understanding the information that's hidden in the data is what probably is the sort of next generation of scientists. And the other thing too is science is not sort of like a monolithic discipline. What I mean by that is really get involved with other disciplines as well that can help you. So for example, me working with Ms. Haynes has really taught me to bring my science and communicate my science effectively with people outside my science. So science is not just laboratory research, but it's really also communicating the research, really drawing in from other disciplines. So keep an open mind. Even though I want you all to become toxicologists and great toxicologists, keep in mind that this can be a very diverse and very broad science, and bringing in people from other disciplines. But if you have the chance, take a coding class. That's something that I tell everyone, including my kids who've not been listening to me.